All right, so we're going to do another day of simplifying radicals. Some of these have a coefficient in front, which we're used to, but again, we're trying to use it without a calculator, okay? Again, when you get to geometry, honors especially, I know they really stress you knowing your perfect squares, and that just depends on the teacher, but this is being able to use without a calculator and building a factor tree using divisibility rules. So again, the ones I focus on the most, which help me across the board, are 2 whenever the number's even, 3, and that is more, I don't really follow this rule, it's more of a visual rule, which I'll show you. 4 again kind of follows the same rule as 3. 5 is whenever it ends in 0 and 5. I never really focus on 6. 7 again is one of those that is a visual thing. 8 I never really focus on because of 2 and 4. 9 I never really focus on because of 3. And then 10 is easy enough if it ends in 0, but also it's divisible by 5. So again, it just kind of plays together. Let's start at the beginning. So number 1, first off, it ends in 0, so I know it's divisible by 10. Yes, it's also divisible by 2, so lots of options there. 10 can be broken up into 5 and 2, no further than that, and 8 can be broken up into 2 and 4, where 4 can be broken up into 2 and 2. There's 2 pairs of 2, so if I bring one of each, that's 4, with the remainder of 5. Number 2, again, it's even because it ends in 2. 2 goes into, so how I do the division without a calculator is I divide across. 2 goes into 7 3 times, but with a remainder of 1, because that's 6. And then you carry the 1 to the 2. 2 goes into 12 6 times. Now, if you look at it, I break up the 36 into 6 and 6. And this is where I have a trick. Again, I could take the 6s further into 2 and 3 and 2 and 3. Ultimately end with the same answer, nothing wrong with it. But since I have this pair of 6s, again, remember, we're looking for pairs at the end of the branches. There's my pair of 6 because 36 is a perfect square. 6 comes out with a remainder of 2, so I can save myself a little bit of time. Number 3, I know it's divisible by 5 because it ends in 5 or 0. If I divide across, 5 doesn't go into 2, but it goes into 27 5 times with a remainder of 2. When I carry that 2 to the 25, 5 goes into 25 5 times. Then I can break 55 into 5 and 11. I can't break up those any further because 11 is prime and 5 is 5. And so here's my pair of 5s, which comes out with a remainder of 11. If I look at number 4, I know it's divisible by 5 because it ends in 5. 5 goes into 45 9 times. Then 9 can be broken up into 3 and 3. Here's my pair of 3s with a remainder of 5. The hardest it gets, of course, is whenever we're talking about a larger number. Now, this is where it's more of a visual trick to me. I don't see this as 567. I see it as 56 and 7, and that makes me realize that it's divisible by 7. Again, it's just more of a trick. I know it's not divisible by 2. It's not even. It's not divisible by 3 necessarily. 2, 26, 24, 2. Oh, it actually might be, but I don't think it is. And then so 7 just pops out to me because when I divide by 7, 7 goes into 56 8 times evenly, and then 7 goes into 7 1 time. Again, it's just more of a visual thing the more you see them. 81 can be broken up into 9 and 9. And let me pause there. Again, I can take the 9s further, but as soon as my ends of branches have pairs, there's my pair right there. 7 can't go any further, but the 9s can kind of stop. I bring out one of the 9s, which I would have done anyway with pairs at the end of the branches, keep in mind. And it has a remainder of 7. Again, just a new trick for y'all. All right, then I look at 150. Yes, it's divisible by 2. Yes, it's divisible by 5. So let me do 10 though, because it ends in 0. It can be broken up into 10 and 15. Now, the reason why I can't stop here is because this is not a pair. So that's why. It only works with pairs. So again, 10 can be broken up into 5 and 2, and 15 can be broken up into 5 and 3. There's my pair of 5s. That comes out. I do have a remainder of 2 and 3, which I multiply to have a remainder of 6. And there it is, okay? But again, we're going to take it one step further because we're talking about what if there's a number in front of the radical, okay? So we do the factor tree like normal. I know 392 is divisible by 2 because it's even. 2 goes into 3 1 time with the remainder of 1. 2 goes into 19 9 times with the remainder of 1. And then 2 goes into 12 6 times. I know that this is also divisible by 2 because it's even. 2 goes into 19 9 times with the remainder of 1. 2 goes into 16, 8 times. Again, 98 can be broken up into 2 again. 2 goes into 9 4 times with the remainder of 1. And then 2 goes into 18 9 times. And then I look at 49, which is 7 times 7 because it's a perfect square. There's my pair of 7s. There's my pair of 2s. I bring out a 2 and a 7, which is ultimately 14. But remember, there's a 6 in front. So I have to multiply 14 times 6. And again, we're not using a calculator. So you multiply the old school kind of way. So that's 84 with the remainder of 2. Again, oh yeah, we missed that multiplication. All right, number 8. 150, again, we kind of saw earlier, so you can sneak a peek back at that one. But it ends in 0, so it's divisible by 10. I keep going, which has a 5 and a 2. 15 has 5 and 3 with a pair of 5s. I bring that pair of 5 out, but remember, it gets multiplied times -2. So 5 times -2, which is -10. And then it has a remainder of 2 times 3, which is 6. Okay, guys, being able to multiply by the coefficient up here is going to be important starting tomorrow and the rest of this unit, because we're not just simplifying radicals, we're taking it one step further to get you ready for next year. All right, number 9. I know it's divisible by 2 because it's even. So 2 goes into 10 5 times with no remainder. Then 2 goes into 8 4 times. I know this one's also divisible by 2. 2 goes into 5 2 times with a remainder of 1. And 2 goes into 14 7 times. And 27 can be broken up into 3 and 9. And then 9 can be broken up into 3 and 3. There's my pair of 3s and a pair of 2s. 2 times 3 is 6, but then I have to multiply it times 4, which is 24, with a remainder of 3. 112. So again, it's even, so I can break it up into 2 and something. 2 goes into 11 5 times with a remainder of 1. We carry the 1 to the 2, which makes 12, and 2 goes into 12 6 times. I can break 56 up into 7 and 8, and then 8 can be broken up into 4 and 2, and then 4 can be broken up into 2 and 2. I have 2 pairs of 2s, which is 4, and then 4 times 8, which is 32, with a remainder of 7. If I look at number 11, I know 3 goes into both, just because of multiplication facts. The technical divisibility rule for 3 is when you add these, 7 plus 2 is 9. Can you divide 9 by 3? And you can. So that's how you know it's divisible by 3. So that's another trick. We'll do another one here in a second. 3 times 9 is 27. And then 9 can be broken up into 3 and 3. There's my pair of 3s, which comes out, but then I multiply it times 3. So 3 times 3 is 9 with a remainder of 3. Let's look at number 12. So I know it's even. I know 2 can go into it, but let me show you how it's divisible by 3. How I know it's divisible by 3 is obviously my multiplication facts, but 4 plus 2 is 6, and 6 is divisible by, divided by 3. So I know it's divisible by 3. 3 times 8 is 24. 8 can be broken up into 2 and 4, and then 2 and 2, with a pair of 2s, which comes out, but then don't forget to multiply by 2, so 2 times 2 is 4. My remainders are 3 and 2, so that's 6. And there it is. Again, we already know how to do this, but again, it's without the calculator.